Hello everybody, welcome back. Let's start implementing classes. Okay, so basically we're going to define classes as you probably already know them, and they're gonna sit here in the grammar, or rather here. So we can already go into the parser. So we go into the source folder, and then our new type of declaration will live here in this function. You can see before we had statement, function, and variable. So we'll make a new one that's called class. And the syntax for these classes is going to be something like this. Or basically like this. We have a class keyword, then we have the name of the class, then brackets that contain all the methods. So it'll look like this. And it's gonna be similar to, let's say, vanilla Python, where we don't list fields in the class definition. So you'll notice we only allow listing functions and not like fields, and we can just add fields as we see fit. Kind of similar to Python, I assume. So the first thing we should do is, if we follow along with here, so he modifies the AST generator, so we should go also and modify our expression class or struct or enum, which is kind of our equivalent of the abstract syntax tree. So it should live here after no, sorry, it should be a statement. And yes, so we have a class statement, which is a name and some methods. And that should be a list of statements again, but specifically it needs to be function statements. But we cannot really say we want a specific type, unfortunately. So let's just for fun, let's check that let's check that we have the class keyword, which we do. So inside the parser we can say, let's put it after the function. So if we get a class keyword, then we will do something. We will say class declaration, and that's it. Now the class declaration function we can define here, and let's mark it as to do. Okay, so of course we need to get the name. So expected class name, or let's say expected name after class keyword. And let me just check the type of this one. It is indeed a token. And then we should consume the left brace, expected left brace, or rather let's do like this. Then let's prepare the methods, and they should be immutable because we're going to add to them. And then we'll say, while we don't find a right brace and we are not at the end, And we can probably remove these. Let me check these functions that they work the way I expect. Anyway, so while that is the case, then we need to read out a method. So let's say, and now we have to dispatch to a different function kind. So we also need to update this one, the enum that we have for function kinds. And then we can push it here. And finally, we need to consume a write brace. And we can then finally return a class statement. So we need we have the name and we have the methods, and I think that should be that. Let's try. Right, and we need to box these, I guess. Do we really need to do that? Well, I boxed it in the other cases, so just to keep it consistent, let's do that. And now there is these error messages because we don't cover all the cases because we added a new case. But let's see here. So where does this function actually use the kind? It doesn't really use it to do anything specific, but I'm sure that will happen soon. But let's keep going on here. Okay, so basically now let's try to fix all of these things. So in the interpreter, we need to handle a class statement. Let me think where to put it. I guess I will just put it here. As name and methods. And I think we just, it's kind of like a function declaration that we just need to store it somehow. Let's wait with that and let's go to the resolver. And I will add it in this random place. We probably don't need these right now. So it's quite simple the way he does it. We don't resolve the methods, we just declare the class. Okay. Okay, now we go to the interpreter. So let's see. So we need the environment and we need to call the define. Is it just Okay, so we need to borrow mutably, then define the name like so. And wait a second. It says null here, which is kind of weird. Let's check the environment. And we insert some value for that. Okay. Whatever. We have to define a literal value, so I'll choose nil. And then we have a class thing. So that should be a new type of value, I guess. Like similar to we had the callable, and here in the function we like assign that callable in the environment. So now we need to, we could do a similar thing. Let me just put to do. So let's do the same thing. And I guess we'll call it lux class as well, which needs a name. And let's call the methods. And I guess we can just now. So in his definition of the class, it only has a string. Only has a name. Sorry. So we could start with that, but I think we will start with that. But basically, I wonder, can I actually do this? I probably cannot. But this is what I want. I want the methods to be a list of callables. Let's see. Great. Okay, anyway. So basically we want a vector of literal values. So actually this could be this could be more than just the methods. But actually it's not enough just to have the value. So like the function itself, we also need the name of the function. So I guess just to make it easy, we'll do something like this, where we have a list of methods, and each method is like the name of the method and then the actual callable. But for now, let's remove that, so we like follow along with the book. So we go to the interpreter again, and then we can make a class, which is, by the way, this one has to be fixed, I think, like so. Yes. And now we make a class, which should be a literal value, lux class. And we just have a name for now. And I guess that is just the the lexeme like that. And then we will just assign that. It's interesting that, let me see, like define takes a string and assign also takes a string here, but in this code it takes the token. So it's a kind of a kind of weird. Okay, so we will assign the class, but actually this has to be a reference. Weird. And finally, I guess we just return okay. Right, or rather we can just let this final assignment be the return value, because that returns a boolean actually. So maybe we say if it's successful then it's okay, and otherwise we say class definition failed for, gonna format it. Now, because I'm accessing a field, I have to do this. See if that compiles. What is the problem? Right, so actually it's because these arms don't turn anything, so it should be like this. What is the problem? Oops, we have like one too many. Okay, great. Great. So let's fix these compiler errors. And let's put them over there. So we have a name, and that's about it right now. And we will just say class name .lexeme. Good. Is it not a token? No, it's just a string. My bad. Okay, and now to type is not. And I guess here we will do the same thing. As for the function, we will panic. Say cannot use class as a falsy value. And we need to do that down here as well. All right. Now to string. How did we handle function? Ah, right, so it's right there. And as always, I will postpone it. Perhaps I should do something else. You know what? Since I'm just doing this all the time, I'm gonna do everything. And in the resolver, we need to unwrap, and this can be the return value. Now we have to do this. Try again. I guess define cannot fail. Aha. We don't have, so let me go back to the resolver, because this is also a mistake. It shouldn't have a methods field yet. And the same here. And I guess I will also remove it here. You know what, maybe we keep it in this statement just because we already did the work. Then we go to the resolver. We need it back, and also in the interpreter, we still need it. Okay, let's then go back and see what's next. And you know what, if we go in here and look at the toString method, yeah, we have, maybe I will do this. And then we go to test cases, and we will say define class. And we will just steal this example. Paste. And it should be not this, it should be class like that. All right, let's try to run that. Perfect. So now we can also try the tests just for fun. Okay, great. So we successfully passed the resolved and all that jazz a class. And the toString method works. So now we can just print a class as well. That's kind of nice. So in the next one, we will look at creating instances. So thanks for watching, and I'll see you later.